Okay, so the next lesson, it's called Using Technology Part 2. Basically, we are going to use that Tvm Solver again. However, we will also be doing things algebraically. Okay, so what I mean by algebraically is working out the formula by hand. Okay, so basically for this, worksheet, we'll be working these questions out by hand, and then checking it with that Tvm solver that you guys worked with in the last lesson. Okay, so all right, so let's just jump into the first example here. So we want to calculate the amount of money you would need to invest now in order to have $6,000 in 2 years if the investment paid an annual rate of interest of 3.5% compounded monthly. Okay, and then how much would you need if the interest doubled? Actually, you know what? I think it means interest rate. So yeah, I copied this. Actually, I copied this question out of your out of the worksheet that comes along with this lesson, and so I think they may have forgotten the word rate. Anyways, interest rate doubled. So we're going to calculate these amounts algebraically. Okay, so this is with the formula. And we're going to round to the nearest $100. Okay, cool. So, so the first thing is going back to compound interest formula. Okay, so that's what we're going to be using quite a bit in this lesson. Okay, so final amount A is equal to the principal times 1 plus R over N times T. Okay, so let's kind of figure out what we're plugging in here. Okay, so we want to calculate the amount of money you would need to invest now. Okay, so this is asking you to calculate or to find the principal. Okay, so the principal is the variable that we're going to be solving for. Okay, so in order to have $6,000, so this would be my final amount. So in other words, this is A in 2 years. Okay, so 2 years, that would be my T. Okay, so T is 2. If investment paid an annual interest rate of 3.5%. Okay, so 3.5%. That means my R is 0.035. Okay, so you're going to convert it to a decimal. Compounded monthly. Okay, so monthly means that N is going to equal 12. Okay, and then we're going to say, okay, so we're going to actually have to do 2 calculations here. Then we're going to do how much if the interest rate was doubled. Okay, so so let's just do the first one here. I know there's a lot of rate going on, but let's just sub in the stuff. All right, so A is 6,000, and we're solving for the principal. 1 plus. Okay, so the rate R is 0.035, and N is equal to, what is N? Monthly, compound monthly, so that's 12. And then up here we have 12 N times T. So 12 times 2 years, so T is 2. Okay, so subbing in the information we have, this is the formula that we get. All right, so we want to solve for P. So to work this out, what I'm going to do is the brackets first. Okay, so the brackets, let's take the calculator out here. Okay, so I'm going to go 1 plus 0.035 divided by 12. And so inside the brackets, okay, I got this really long decimal here, but I'll just write down 1.0029 and dot, dot, dot. Okay, so so remember, we're going to do the rounding at the very end. Okay, so when it comes to these calculations, we want to leave the decimal in there. Okay. Now 12 times 2 is 24. So my exponent in this case is 24. Okay, so next up, 6,000 equals. Okay, so this number here, I'm going to work that one out. So I have that 1.0029, blah, blah, blah. All right, so I'm going to raise this to the 24th power. And we get 1.0723. Okay, so 1.0, sorry, 723. I think there's a 9 next, right? Dot, 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 times p. Okay. So to divide both sides by that, okay, so those would cancel there. So p is going to equal, all right, so this number here I'm going to divide by, does this have a memory? Okay, so I just want to store this thing in here, so maybe that will work. Oh, I guess we'll see. All right, so 6,000 divided by, this should be memory recall. Yeah, there we go, memory recall. Okay, so again, I haven't rounded anything, I left everything in the calculator. And we get an answer of 5594. And how much? 93 cents. Okay. Now, the question itself is, it says here, round to the nearest $100. Okay, so this here I'm just going to round it. Let's do a squiggly line. So this is just rounding it to, that would round to 5,600. Okay. Okay, so that would be if we wanted to, the initial situation there. Now what I'm going to do is, rather than going into the next one here, I'm going to actually just do this quickly with the Tvm solver that I showed you on the last lesson, and just make sure we get the same numbers here. Okay, so just pull that up. Oops. Okay, so here I'm just going to plug in the value. Okay, so present value is what we're trying to find. We're trying to find the principal. Our payments were 0. The future value. Okay, so again, when you're working with this thing here, we want the future value. Oops, I don't want. We want our future value to be negative. Okay, so it's 6,000. Okay, it's just the way this thing's set up. You got to punch it in as a negative. The annual rate was 3.5%. And the number of periods, okay, so that's compounded monthly for 2 years. Okay, so basically the number of periods is the exponent here. That's 24. It's compounded monthly, yes. Okay, so the present value, boom, 559493, which is exactly what I got here. Cool. Okay, so anyways, that's, yeah, doing this work here and using the Tvm solver to check it. All right. Now the second part of this is, how much would you need if the interest rate was doubled? All right, so yeah, we're gonna have to redo this calculation, plug in stuff in, and instead of using 3.5%, we're gonna double that rate to 7%. Okay, so okay, so double. Okay. So double R. All right, so let's plug that stuff back into the formula. Okay, so just going to write up the compound interest formula again. Okay, so this time, again, final amount was 6,000. I want to find the principal. This time my rate is 7%. Okay, so I doubled it from 3.5. Still compounded monthly for 2 years. Okay, so all the other numbers are the same except for the R. Okay. All right, so same steps here. This time I'm just going to kind of do this fairly quickly here. So let's punch that in. Okay, so 1.0583. dot, dot. And the exponent still is 24. Okay, so what's that number there? We'll reset to the 24th power. .149. Dot, dot, dot. Okay. So next we're going to divide by that number. And see what we get. Okay, so I'm going to store that in my memory. Take 6,000, divide it by, oops, no, that's not the number I wanted. So let's try that again. Okay, 1.058. Yeah. You know what? I just realized is that we're going to be rounding to the nearest $100. No, actually, you know what? I'm not going to take shortcuts. I'll do this again. So 1 plus point. Yeah. It's just clear. Okay. 1 plus 0.07 divided by 12. Okay. To the 24th power. Okay. So we got that number. And then, oh, that's right. I wanted to clear the memory before. Okay, so let's clear the memory and then add this in. There we go. This should work. All right, so it is 6,000 divided by that. There we go. So $5,218.27. I say 27 cents. 27 cents. Okay, now when we round it to the nearest 100, that's 5,200. All right. Do I want to use the Tvm Solver? Yeah, let's just do that because everything's the same except this thing here. All right, so I'm just going to change the rate there to 7% and the menu present value 52.1827, all right, which is 52.1827. All right, cool. That's what we got. All right. Okay, so yeah, so for today's lesson, we're doing these algebraically and basically checking with the calculator. Okay. Now the other one here is when we're solving for the interest rate. Okay, so this is the next example. This one, yeah, it could be a little bit more trickier, but I'm gonna walk you through it. Okay, so again, starting off with the formula, A equals P 1 plus R over N times T. Okay, so this time I'm trying to find the annual rate. So we're going to be solving for R, compounded monthly. Okay, so N is 12. Triple. Okay, so we want to triple this thing in 20 years. Okay, so T is 20. So what would the rate need to be? Okay, so this question here, it actually doesn't tell you the principal or the file amount, but this is the key thing here. We want it to triple. So in this case, what you can do is you can just make up a principal, and as long as the file amount, the future value is 3 times as much as that. All right. So for instance, let's say I start off with, I don't know, I'm just going to go with $100, and I want to triple it to 300. Okay. So as long as this is 3 times, you should get the same answer every time. Okay, so so let's sub that information in. Okay, so I got 300 equals 100. 1 plus. Okay, so the rate is what I'm solving for. N is 12. And again, I got N up there, and this time it is tripling in 20 years. Okay, so T is 20. Okay, so to work this out, what I'm going to do first here is actually multiply the exponents together. Okay, so 12 times 20 is 240. Okay. Now I'm going to divide both sides by, so to solve for r here, our first step actually is to divide both sides by 100. So these cancel. And what you'll notice is on the left-hand side here, it's equal to 3. Okay, because we start off with 100 and went to 300. So if you imagine using like different numbers, as long as this principal is like, as long as the final value is 3 times as much as this, in our first step, we're going to divide 3 by that principal, and we will always get a 3 here, right? No matter what two values you chose for A and P. All right, so 1 plus r over 12 to the 240th power. Okay, so this is where we have to get rid of the exponent. Okay, so to get rid of this exponent, there's a couple things you can do depending on your calculator. Your calculator might have this button, right, which allows you to get like the xth root of this number. Now, some calculators won't actually have that. Okay, so I just want to look at mine here. Actually, might be under here. Actually, yeah. So my calculator will have this, so I can find the like 240th root of 3. Now that being said, some calculators won't have that. So I'm going to use I'm going to show you another method too. Okay. So what you want to do actually is raise each side to the 1 over 240th power. Okay, so what that does is with exponent rules, right? If you have an exponent outside an exponent, you multiply them together. Well, 240 times 1 over 240 is equal to 1. So basically, this is canceling this out. Okay, so I want to take 3 to the 1 over 240th power. Okay, so let's do that on the left side. Okay, so 3 to the power of bracket 1 over 240 equals. All right, so I'm going to get this number here, 1.00458. Dot, 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 equals, and then I got 1 plus r over 12. All right, actually, you know what? I think what I'm going to do is just show you I should get the exact same number if I use this button. So let me do that. Just going to make sure I punch it in the right way. Okay, so it's going to be, yeah, so 3, and I want to find the, oh, I might have it backwards, sorry. Oh no, I punched it in the right way. Okay, so notice I get the exact same number here. Okay, so this is the 240th root of 3. Okay, so either way you want to do it, you should get this number here. Okay, so make sure you know how to use that on your calculator. Yeah, so at this point, I had to show you both ways. Okay, it's convenient to have this button, but if you don't, then you would have to raise it to the 1 over 240th power. Okay, so the next step here is to take the 1 and move it over. So I'm going to subtract 1. And so basically that just cancels this. So I have 0.00458 equals r over 12. Okay. Okay, so I'm going to subtract 1 from there. Okay, so I got this number here. And then final step is to multiply both sides by 12. So these cancel. Okay, so r is going to equal, if I multiply by 12, we get 0.055. Okay, so that is 5.5%. Okay. All right, so now let's just check that quickly with our Tvm solver. Okay, so all this stuff, all these numbers here will be. So my present value, okay, so I wanted it to triple. So let's just say I have, you know what, I'm going to use a different set of numbers just to show it, but it actually doesn't matter. As long as your present value is, or your future value is 3 times as much as the present value. Okay. So here I just went 25 to 75. Okay. The rate is what I'm trying to find, so I'll leave that blank. Number of periods, it was, I believe, 240. Yep. So compounded monthly for 20 years, so 240 compounding periods. And compounded monthly. All right, so let's see what the rate gives us. Okay, so you'll see there is 5.506. All right, which is, yeah, 5.50. Yeah, if you round that to 6, but it's 5.5%. Cool. I have a feeling there's a, oh yeah, here we go. Okay, I thought there was a second part here. What would be the interest rate if you compounded daily? All right, guys, not gonna lie to you, I don't really feel like doing all this stuff again. But if you were to do it by hand, you would replace the 12 with 365. But let's just do it this way. All right, so I'm just going to have to change the number of periods here. So it's as well as compounded daily. All right, so compounded daily. Compound daily, so 365 for 20 years. So I'm going to multiply that 365 with 20, 7,300. 300 compounding periods. Our new rate would be, actually, if it was compounded daily, would you need a higher rate or a lower rate? Okay, so if you think about it, it's being compounded more often, right? So therefore, the rate should be lower. Okay, and you can see it, yeah, slightly lower. Okay, 5.493 as opposed to 5.505. Okay, so a slight difference, not that big of a difference though. Okay, all right. So yeah, so if you were to do all this with n equal to 365, so basically these two numbers here get replaced with 365, do all the same work. It's going to end up with your interest rate of, again, 5.5% if you work around it, 5.493. All right, cool. All right, so we'll just take a quick look at your worksheet. Technology part 2. Yeah, so you got 6 practice questions here. Answers are on the bottom. Yeah, so, and you'll see that, yeah, it's either solving for the principal, which are these ones here, or solving for the interest rate. So what's the interest rate? Cool. All right, guys. Hope all is well. Take it easy. Talk to you later. Ciao.